Hi guys, this is round 2 of our cheat sheet on how to use Markdown to write fully reproducible manuscripts. So we're going to cover in this video is a little bit more on Papaja and some functions in Papaja I've learned about in this last week, as well as how to make tables, specifically focusing on how to get output out of a one-way ANOVA. So a little bit of these guidelines are going to follow along with my graduate statistics course, but we're also going to cover how to do citations and some other things that you would learn, maybe in a writing course. I'm working on putting all this online on a reproducible science page on our website, and so I'll have the link for that below after I get it uploaded this week. So what we've done is create this document that sort of walks you through everything I'm going to do today, and then I have an example of a simple one-way ANOVA from Andy Fields using statistics textbook to use as our work-through guide. Okay. So the first thing, you have to have Papaja installed, and so I have the notes up here on how to install it. You also need dev tools if you don't have that library already. I have all this installed, but if you go to Papaja's GitHub page, there's a whole lot more information than I could possibly ever cover. So I always just search Papaja GitHub or Git, so that you don't just get pictures of fruit. And so here we go. The GitHub page here has tons of cool information on how to install, how to knit from PDF, and some sort of how-to guides as well. So we're complementing this page. Anyway, all right, so once we've got it installed, I'm going to load the Papaja library, the Mote library, which I don't know that we'll actually use too much today, but also knitr to show you how the cable function works. And so what we did last week was we talked about how to pull numbers from chunks. So running them here in my Markdown chunks, my little R script within a document, and report them outside the chunk. And we talked about the APA function that I have in the Mote library. Papaja actually has a very similar function. So the good thing about following the fantastic creator on Twitter is that he will tell you when you've missed things. So I'm going to also talk about his two functions that do the same thing as the APA function, so whichever one you like better. So I'm going to run an example from the Andy Field to have some data to work with to show you how some of these things work. So I'm going to use the Haven library to import from SPSS. This is a fairly newer library, at least to me, and I think it works a lot better than Foreign or Mimisk at importing SPSS files. So I'm going to import that data set, and then over here I'm just going to click to view it. Okay. And so what it has is a dosage of Viagra that a participant might get, and then their libido levels that they reported. And so the Viagra dosage is actually, when you import from SPSS, is saved in this weird atomic category, and it's placebo low and high. But since that is not actually a factor, that's not going to run very well for us in a easy ANOVA or LM. So we're just going to go ahead and kind of factor that. There is a participant number, but I wasn't paying attention, so I added one anyway. So we're going to use the easy library, which runs ANOVAs and lets you control the type of sum of squares pretty well. So if you want to learn a lot more about easy, I have a bunch of videos that cover between subjects, repeated measures, and mixed design ANOVAs. So I'm going to add my participant number. I know there's one there, but it was late and I didn't realize it at first. And then I'm going to factor my dosage variable so I can get Levine's test. This next line just turns off scientific notation so I can see all of the 800 decimals for P. And what we'll do is normally you would just run easy ANOVA. Okay, so I'm going to run it over here, and it's going to show me my output for easy down here. So it looks a little weird when you're using Markdown because it shows me my warning where it converted my participant number to a factor, no big deal. But then it shows you the data frame that you get for the ANOVA function. So we would be interested in this information here. There's a little right-click arrow here because GES is also hiding out here. For generalized effect size, which in between subjects ANOVA is eta squared. And then it also shows you the data frame for Levine's. So it looks kind of odd. But since we want to use it later, we're just going to save it as easy output. And then I could tell it to show me the output down here if I wanted to look at it to see, is this even significant? The other way that we could do this is run a one-way test. So if Levine's test is significant and we wanted to correct using a Welch correction, we might use oneway.test. And I'm going to save that as Aov Output. And that will actually pop up over here, and it shows us that this is, the p-value is 0.054 if I round up. And it corrects by changing the degrees of freedom denominator. So this would be if I had heterogeneity. But then I could also run this as a regular regression type model using LM. And so that LM output is not very useful, but if we use summary of the LM output, this will be, we can get this in regular regression style summary, or I can actually do summary.aov, I think. We'll see. Yes, okay. LM output to look at the traditional ANOVA format for this. Okay. So that gave me my sum of squares table. Right. Either way, so that's 3 different ways to run ANOVA right there. One of them is a corrected ANOVA. But we talked a little bit last week about APA print, which is this really fantastic function that will take information from in R, these are called S3 and S4 class objects. But generally, this is anything that comes out of an LM function. So anytime you're using a linear model, or AOV, which is just a special wrapper for LM, meaning it's the same math in the background. So APA print works on those. Okay. Does not really work on easy. So we'll see what happens when we try that in a minute. It's commented out for a reason. Okay. So the way the APA print works is like you do APA print, open, close parentheses, and you put the output that you've saved in between the parentheses. So here we could try APA print AOV output. And depending on what that output is, we get different things. So let's look at what happens with easy here, since it does not work for easy because it's not the right type of class. Essentially it just kind of goes, nah, not doing it. Okay. So it's not the right format for us to use that function, so we'll have to do something else. Okay. However, APA print on AOV works okay. So it shows me the statistic here. So it pulled F and P, but it didn't pull the degrees of freedom because it's not formatted in quite the right way. So we could have all these other options, but because of the way that one-way test saves, it didn't give us anything other than just statistic here. Okay. So if we wanted to use that particular one-way test, we might have to format it ourselves. Last, on real LM output, we had a bunch of stuff. And so I find it easier to look over here. So let me scroll up some. There's a bunch of different things. So I can get the estimate table. So this would be like each coefficient in a traditional regression, right? So I've got the intercept, dose 1 versus dose 2, 1 versus 3 in dummy coded scheme format. So that prints the B value and the confidence interval for B. I can get just R squared and its 90% confidence interval. I can get adjusted R squared, AIC, BIC, wait, we're going to keep going, the statistics for each of those coefficients, the overall model fit statistic, or your best bet is the combined options under full result, where I have the intercept and the statistic, or the overall full result together. And so you got lots of options. And the nice thing is that each one of these has how you call it. So if I wanted to only pull, let's say, just the model fit, the F here, so copy that. So do APA print, this is LM output, and I'm gonna stick a $, and then paste that one on the end. Oh, there's already one there, sorry. So I've copied it from up here. I want this F number, so I'm going to copy this here, and that will tell me and only pull the one I'm interested in. Okay. So it's nice to print it out while you're looking at it in Markdown because you could pick which one you want to report. Or if you wanted to report all of them, you could call them one at a time. So that's the only reason I would say print it out in the chunk as you're learning how to do this. And then I would comment it out or tell it not to show that when you knit so that you can reference it outside the chunk. So for the Aov output, this doesn't do us a whole lot of good, but I can print it out by using my little R brackets that we talked about last time. And the only option I have was the Aov output and then statistic. The rest of them were null. And I'm saying that's probably not the best since the degrees of freedom are missing. So we'll talk in a second about how do I manually pull numbers. And then LM output works the best because that's what it was designed for. And so I told it to print the entire full model fit result for me, but I could have picked any one of these options. So let me pull up my Word document here. I've already pre-knitted this, although I did learn some things about knitting when doing this. So this just shows me all the output because I haven't told the chunk. Remember, you can tell chunks not to be viewable, but since I'm trying to teach what's going on, they're going to be viewable now. Scroll, 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 all the different options here. So it created a lot of output. But you can see that when I told it to do that little R chunk, it gave me F and P, but it probably want to report the degrees of freedom, especially because this is a correction. And then under the LM output, I have my R, my confidence interval for R, F, and then P. If you wanted to reorder those, you could report each one separately and do F first and then R. So let's say I wanted to do F first and then R. I could tell it to give me a chunk where I used APA print, LM output, right, $. Now over here I would just look until I found F. So the one with just F is here, statistic model fit. Okay, close chunk. I'm going to do comma, open a new little mini R chunk, APA print, LM output, $, and then I would pull wherever just R is at. So here's the one for R. Okay. And the big difference here is this one says statistic model fit for F, and this one says estimate model fit for R squared. Okay. And that would allow me to print them in the order I wanted. So if I wanted F to go first. Now what do I do if I can't use LM? So I like Easy ANOVA, I'm attached to it, or better yet, my statistics teacher has taught me Easy ANOVA, that's the only thing I really know how to do. What I can do is pull the numbers that I need dynamically using what I know about the matrix that this prints out. So the nice thing about Easy ANOVA is that it saves the information as a little data frame. And we've talked previously in my class and on this channel about how to find specific numbers in data frames. So if you want to print the whole ANOVA table, warning in advance, when you're using Markdown, you can't really get it to tell you to print a data frame that I found. I think this was my problem last night, where I told it to just print like this. So I was doing R, easy, output, $ANOVA, because that works. So if I ran that over here, it shows me a little table. But for some reason, that particular set of code doesn't want to print, and the error message is essentially like, bleh. So I figured out that I could use the cable function here, which is a type of table in knit-R, to print this out as a little table. So it will print out my summary table in table format, and that solved my problem. So here's where I printed the whole table. So here's what cable looks like when you print out a table, which is close to APA style. But I probably wouldn't really want to print the table, like, unless it was a homework assignment. So instead, what we're going to do is just pull the numbers we need to do APA style. And I understand matrices, and this thing is a matrix, so I can figure out where the numbers are. So let me move this over and show you how I got to where I got. So I typed easy output, and what I tell my students to do is hit the $ and see if something happens. If something happens, you can use that sort of formatting. If not, you can't. Okay. So this is saved as a little data frame where this is row 1 and this is row 2. So what we can do is tell it to just pull row 2 for us. So 2, comma, and then nothing. That'll give me the whole row. And so now what I can do is figure out what part, maybe let's go degrees of freedom numerator. So it's clearly on row 2, and now I'm going to count 1 for dos, 1 for 2. And I just do that until I find the number I'm looking for. Because you can't totally do, you can pull these as well, so I can do the $sign. So there's more than one way to skin a cat here. So I can do dfn for degrees of freedom numerator, and that gives me 2 of them. So there's not another $sign, so I could also do 2 here. Either way works appropriately. This way might be clearer what number you're pulling if you like this format. I did my whole one in matrix format. So I want row 2, I want spot number 1, spot number 2 is how I did it. Both ways work for easy ANOVA. So what I did was I figured out degrees of freedom 1 here is 2, 2. Degrees of freedom 2 is 3, so 1, 2, 3. F is 6, 4, 5, 6 over. P is 7, 7. This star counts as number 8, and FX size is number 9. And so I just was pulling them one at a time to see if I could make sure that they matched what I was expecting. So I actually did this in the console and just kind of made sure the number was what I thought it was. So I think this is effect size, and yes, it is effect size. So let's go back. Oops, wrong one. There we go. And so I just had it pulling the numbers for me. So you'll notice that we're going to have to do something about all these decimals, because if I tell it to just print like this, first of all, that only printed 1 degree of freedom. And then second of all, I didn't notice that last night, but second of all, there's a lot of decimals and I want to lop those off. And then P and eta here should definitely not have a leading 0. But clearly, I can pull all this together into what I would consider nice format. So it prints out nicely. However, in Markdown, it looks a little nutty. So let's put this together. So I used the stars here around F to create italics. I told it to open parentheses. Whoopee, open parentheses. Here's my first R, mini R chunk where I told it to give me the first degree of freedom. I closed that chunk, hit comma, did the second R chunk, right? Close the parentheses, put in my equals. My next R chunk with the APA function from Moat. So I told it to do APA, you do number, the number of decimals you want, true or false if it has a leading 0. So F can have the 0, it can go over 1, comma. Now I'm going to do P equals because my P value is not less than 0.1. And then my APA format, I want 3 decimals here, but false, it cannot go over 1, comma. I did the eta symbol. And so when you hover over these and you do them correctly, it shows it to you. So I need the $signs to indicate that I'm going to do this as a symbol or as formatted math type. The backslash allows me to type the Greek character name that I'm interested in. If you want a capitalized eta, you just capitalized it. Okay, that didn't work for that one. It works for delta, but apparently not eta. The caret up 2 to get eta squared, okay, and that will automatically italicize it. And then I did the same thing here. So my APA output, 2 decimals, false for leading 0. So it ends up being a lot of code, but let's say you have a reviewer who's like, oh, you shouldn't have excluded outliers. Run the whole thing again without the outliers. Now I can just change my R chunk that maybe excluded those outliers. I can say this time include them, and this will dynamically change my F statistic here, because that will have changed the entire line. So as an aside, I think I said last week that you might need the MakeTech or MagTech LaTeX to install. You don't need it to print to Word, only to PDF. So the symbols are not dependent on that in the background. So I'm learning new things by posting these things on Twitter where I say, I don't know if I know the answer, and then somebody will tell me what it is. So let me talk a little bit about post hoc. So that is 2 different ways printing when you can use Papaja and printing when you can't. Let's talk a little bit about post-hoc tests. So I'm going to run pairwise t-test with a Bonferroni correction, and I'm going to tell that to save. So when you save those, it actually will save a little mini data frame of the p-values, which is usually what you want, and it saves them as another little matrix. Now the nice thing about this particular matrix is that I can call the numbers as 1, 2, 3, 4, and that goes down and then across. So this one's 1, 2, 3, 4. Or I can use the matrix format and say that this is spot 1, comma 1. This is spot row 2, column 1, row 1, column 2, and 2, 2. So you can actually use either format. And the way I figured that out was just hacking at it. So p.value, I can't use another $sign, so I got to use my square brackets, and I just typed 1 and saw what happened. Okay, and that gave me the first one here. And then I tried the same thing, click 2, and that gave me the second one here. Now the interesting thing is 1, comma 1 also gives me this first one. So I always tell my students when we start the semester that in R it's not can you, it's how many different ways can you. And so those are 2 different ways to pull the same values. And I would tell you whichever one makes the most sense to you is the one to use. So just like with EasyAnova, you can do double $signs. I would say if you're good at matrix format, to do it in matrix format. Otherwise, just kind of play with the numbers until you find the one you're looking for. And so the important part about this is that it would be very easy, just like it would be easy to type the wrong number into Word if you were manually typing your statistics from output, it would also be very easy to tell it to pull the wrong number. So just making sure that you've got the value you are expecting given the output you were looking at. So with these p-values, I wanted to talk a little bit about Papaja's built-in number formatter, which works the same as APA from Moat, which is printnum and printp. So printnum works by putting in the number. The second argument is GT1, so this stands for can it get greater than 1? So you put in true or false. And that deals with the leading 0. So if you say true, you'll get a leading 0. If you say false, you will not. Third, 0, true or false. And this is if the number can literally be 0 or not. So like p-values can't technically be 0. So this will give you like a less than symbol if you cannot be 0, but the number rounds to 0. Fourth, margin. Margin is 1 for matrix, or 1 for rows, 2 for columns. This is like the apply function. So if you're gonna use this function across an entire column or an entire row, this allows you to control for if it goes, it's like rounding down or across. Okay. There are a couple of other options, and if you want to see them, you can do question mark in your console, print num, and that will pull up this really handy help page that covers each one of the different options that you can use. So what I could do is I could say f equals and use printnum. So I pulled my f number here, and then I left it alone because the default options for greater than 1 is true and for 0 is true. So I just didn't add anything else. And you can see that that printed out, once I get through all my p-values here, as a nice rounded 2 decimal point number for APA style. If I wanted to use Ada, what I could do is say printnum, I could get my Ada number from EasyAnova, and then I say greater than 1 equals false. Okay. But Ada could be 0, be highly unlikely, but it could be. Just like F in theory could be 0, highly unlikely. Back to Word here, sorry. And what that did by using the false, greater than 1 false, that turned off the 0. So that's another way to control the leading zeros. Let's say you wanted more than 2 digits because, let's say some reviewer asked you for 3. printnum will also allow you to pass the digits command through. And so that's one of the format options that it says here, ... Further arguments, that's under format. So I could tell it to give me 3 digits instead of 2. Okay, the default is going to be 2 unless it's a p-value. Printp is a separate option that essentially is a special case of printnum when the value is for p. So you don't have to use greater than 1 equals false and digits equals 3. It sort of assumes that you want 3 digits and it knows it cannot be greater than 1. Okay. So the way that works is printp. So I did my p-value from EasyAnova, which is greater than 001. And then I did an example where it's less than 001 so you can see what happens. And so when it's greater than 001, it rounds it to 3 decimal places and leaves off the leading 0. And when it's less than 001, it adds the little less than symbol and automatically makes it 001. And so this was a great way to not list p as 000, which is inappropriate. All right, let's finish up here by talking about post hocs. Okay, so this is where we ended when I had to take a break, and now I'm back. So let's talk about printing that post hoc information. So pulling those p values from our post hoc test that we ran, what I can do is take them where, sorry, come back to the console here. I had pulled, 1 or 2, and use that using printp to print each one. But what I would want to do is make sure I understood which ones are going to be less than 001 and which ones aren't, because that'll change how I put the numbers around them. So I can say 1 versus 2 here is not significant using traditional 0.05 alpha. And so I would say p here to get the italics using the little stars equals, and then to print out the p-value using printp. While 1 versus 3 is significant, but since that's 0.025, I still want p equals to match APA style. And 2 versus 3 is not significant, and so p equals as well. And really the concern here is if you have any that are less than 001, you'll leave out the equals because printp will automatically give you the less than sign. And then we'd probably want to include the effect sizes. And so if you watch the video from last week, that is covered in the Moat library on how to pull those values from and their confidence intervals to report with your post hoc test. Okay. So let's talk about printing in table format. So I covered the cable function in my sim class from the summer. So if you watch any of the videos on how to work some of those assignments, I talk about how to create tables. So there's another video already that if you want to watch more on creating tables, I have some more examples. But the way APA table works is that basically you need to build yourself the table, and then APA table wraps it and makes it nice and pretty. So the first thing we're going to do is create a blank matrix and put all of my information in it. And then use APA table to format it in the nice style. So when you're doing tables, the R chunk information, at least when you're wanting to print the table only and not all the extra stuff, is echo equals false, as in don't show this stuff, results equal as is. So this will print out the table the way it is. Okay. This is an important part that's got to be on there to print out tables in like the full Markdown manuscript examples, and I only this semester had a student explain to me that was as is because I never got it until then. So it kind of looks like ACES, but it's present the results as is. The way I'm doing this is just makes sense to me. There are lots of different ways to do this, but essentially I made myself a table that I'm calling table print, and I made it a matrix. I filled the matrix with NA values, and this is a 3x4 table. So when you do that, you can kind of watch as you're going, filling this in so you get used to it. So I'm going to tell it to print out my table, and right now it's got 4 columns, 3 rows, and those are all blank at the moment. What I'm going to do then using matrix format is fill in the rows one at a time. You can also fill in columns one at a time or one piece at a time, but this is a little faster. So for each row, I'm going to fill in some information. So this says for table print row 1, fill in row 1 as column 1, 4, 2, and 6. So let me just run that real quick. Type table print over here. Okay. So that filled in my table, and it treats these as characters because a matrix, it being a matrix requires that each of the things are all the same. So the nice thing about data frames is that one column can be numbers and one column can be words, but in a matrix they all need to be the same. So you could also do this as a data frame. Matrices just made sense to me. Now in the next one, I'm going to fill it in with my p-values that I'm pulling from the post hoc test that we ran earlier. And when we do that, it does automatically convert, sorry, it's table print. I don't want to call it just table because calling it table, that's a function in R. And so we don't want to call saved variables in the name of functions. So it does automatically convert those to characters, but that's okay. Because now what I can do is in the third row, I can mix and match. So now they're all going to be characters, and all of my NAs are filled in. But these are kind of ugly. So let me show you down here. Oh, that didn't totally work. Let's try to make it bigger. And so what I'm going to do is I'm going to fix these to be particular numbers, nicely formatted numbers. So what I want to do is for row 1, columns 2 through 4, so that's just 4, 2, and 6. I'm going to use printnum that we were using a minute ago to fix those. So printnum will automatically assume that you want greater than 1 to be true and 0 to be true and give you 2 decimals. So that's going to change row 1 here in table print. Row 1, which right now is 4, 2, and 6. That will make it 4.00, 2.00, and 6.00. Okay. Now I have to do this as .numeric because it converted them all to characters. Okay, so let's look at that now. And so that just formatted my numbers for me. Okay. Now I can use printp to fix 2 through 4 here across the entire row minus the first column. So fix row 2, columns 2 through 4, and make those p-values. Okay, so I want row 2, and then now my p-values are all formatted correctly instead of looking like this big, huge, crazy mess. Now you can do that manually on each individual number, but it's much faster to do it after you filled in all of your numbers, and you can change the whole column or the whole row. So this allowed me to have a little bit more control of doing them all at once instead of doing it on each one of these p-values here. Okay. So there's a couple different points in which you can format the numbers. I just find it easy to format them once they're already pulled into the table I'm making. Now the way the APA table works, there's a lot of different options, and it uses cable in the background. And so any option that you can pass into cable, you can also add. And so I always just use the help page to help me figure out what I need. But the first thing you want to put in is the name of the matrix or data frame or list that you want to print. Caption is the one that goes at the top. This is normally in italics. Note is the one that goes on the bottom next to the word note. Align here tells what alignment to put each column. And so I found it's very flexible that if you leave some of these off, it just will assume center, I think. But it allows me to align the first column as left and then the next 3 columns as centered. And even though it's not on the list of options over here in the help, call.names is something that you can pass because of cable, and this will allow you to put in the names of the columns. You can also, if the table itself has column names, it will read those, but I found this is a little easier because it will allow you to put in symbols that you normally would not be able to use. And so this will put in the name of a column in a matrix. It doesn't really want you to use, to start with a number, but here you could put it as like 95% confidence interval. Okay. And this will also allow you to italicize by using the $signs. Okay. You can also turn on landscape or small. So small is a really useful option if you have a very large table. Okay. And there's even more options than that. I'm not even covering most of them. This is like just the basic idea of tables. But if you can get this far, usually you can work on the little bitty formatting things. Now, options in Word are not the best. So when it prints the table, this is a reference for the table. And so it kind of hits APA style. I mean, the whole thing is in Calibri, first of all, but you know, it does the best it can do, given the limitations on Word. So this is pretty close. I would just have to format it a little better. But if you knit this to PDF, this is where Papaja really shines, in my opinion. Is that it automatically creates the name, the name of a table, and look at how beautifully formatted this is. So this is like very nicely put into APA style. And I'm still learning a lot of the little tricks on how to make this look, you know, add extra lines and stuff. But this is what you can end up creating when you knit to PDF. The thing that you're going to have trouble with, though, is like you can't, so the example here I've built is just built as a Markdown Default. So I hit New, Markdown, and just did the default one. So this is because I do this for my students, so it says enter your name. If you want to actually knit to PDF in the APA format, you'll click From Template, APA 6, hit OK, and then what I did was I just took my cheat sheet and threw it into the bottom here to make it knit in the pretty format. But that's kind of the ultimate goal, is to use Papaja to create a reproducible manuscript. But if you're just trying to create tables for yourself, it is going to look a little different. So this is what Cable looks like when it prints to PDF, where it looks a little different in Word. And so I personally try to always do to PDF because I think it formats it a little better. There are less limitations due to Word. But if you're trying to work with maybe some other researchers, what we've been doing is knitting to Word, letting them edit the text, and then changing it on our end, and then the version that goes to the publisher when we submit is the PDF version that looks the most APA stylish. If you want to edit the Word version, you can do that too. All right, so we covered everything from printp, printnum, how to use APA print when you have LM type objects, and then also how to print tables. And so one of the next videos is going to cover citations, but we'll keep doing these as kind of a weekly series given different analyses types. So this really covers ANOVA. And then so next week in my class we're doing between subjects ANOVA with 2 IVs. So we'll talk about interactions and also how to make graphs appear and label them with figure captions in Markdown using Papaja.